Hello everyone. In this video, we will discuss on how to calculate resistance on the parallel connection or on series connection. As well as in this video also, we will be discussing on how to identify the condition of a specific resistor. So let's start with here. So this schematic diagram here above, this part in here is our example for a series connection of a resistor in the circuit. Now, based on this connection, it is called series because this resistors has only one path of the current to flow towards the output. So it means, or towards the input power. So that means that once you remove one of this resistor from the circuit, then the circuit will become incomplete because there's no more complete path of the other resistors towards the source. Okay? Now, here below, this schematic here is our example of a parallel circuit. Okay, parallel circuit, it's because this resistors here has its individual path towards the source, so it means towards the power. Once you remove one of these resistors, then the other resistor will still have its path towards the source. So for example, if I'll remove R1, then the R2 will not be affected towards the source. While on the series, once you remove one, then the rest will no longer have its complete path towards the source. Now, in this video, we will be discussing on how to calculate the total resistance if the resistors are connected in series, as well as we will also discuss on how to calculate resistance reading or total resistance once the resistors are connected in parallel. Okay, let's go. The first question is, what is the total resistance in series connection? So, the answer is, the total resistance in series connection is the sum of all resistance connected in series. So it means those resistance connected in series are just going to be added. You will just add those resistance connected in series to get the total resistance. So we have here the formula. So the formula for series, we have the total resistance, that is RT or R sub T is equal to R1. This is referring to R1 is referring to resistance 1 or the first resistance on your circuit, plus the R2. R2 is the resistance of your resistor number 2 in your circuit connection. Then plus R3. So that means the third resistance on your circuit, plus Rn. So it means if there are lots of resistors connected in series, then all you need to do to have the total resistance of the series connection is just to get the sum. It means to add all of the resistance connected in series. Okay, let's have here a sample diagram. So in this diagram, R1, R2, R3. So if whatever is the resistance of R1, R2, and R3, all you need to do to get the entire or total resistance of these resistors connected in series is just to get the sum or to add all of the resistance. So for example, R1 plus R2 plus R3. So it means you are going to use only the formula here, RT equals R1 plus R2 plus R3. So let's have here the example. So let's solve for the total resistance. So these are the given. So given value here. So R1 according to this given is equals to 2 ohms. R2 based on this given again is equal to 4 ohms. Then R3 is equals to 6 ohms based on this given data. Then we have here the given diagram. So this is the diagram of these three resistors. They are accurately connected in series. Okay? Now, here is the solution. Since they are connected in series, we can use this formula. RT equals R1 plus R2 plus R3. Since we stop on R3 because we only have here in this example 3 resistors. So it means we are to stop here. But if we have the fourth resistor, then we are going to place here plus R4. Okay, I hope that is understood. So we have in here, we are going to substitute this value because based on the given, these are the equivalent resistance value of the R1, and this is for R2, and this is for R3. So we get in here, we are going to substitute, so change R1 into 2 ohms since that is the given value. So that is RT equals 2 ohms plus 4 ohms. 4 ohms from R2, that's the value of R2. Then plus 6 ohms. Now 6 ohms is coming from the value of R3. So what you need to do in here is to get the sum, that is 2 plus 4 plus 6. Then we can have here as our total resistance here is 12 ohms, because 2 plus 4 plus 6 equals 12, and the unit here is ohms. Now our final answer for this example, our total resistance is equals to 12 ohms. I hope that is clear, and if you have questions, do not hesitate to ask it. You may pause this video if necessary. Okay? So next question is, what is the total resistance in parallel connection? So that's it. Okay, what do you think? So we have here the total resistance in parallel connection is lesser than the smallest resistance value in the circuit. So it means, for example, if you have a 1000 ohms in connected parallel to 1 ohm, it means its total resistance should be lesser than 1 ohm. Because if not, then this statement in here is not correct. So let's try to find out once we have here the I have here the example. Then let's try to find out, let's try to solve if it is correct that the total resistance value in parallel connection is lesser than the smallest resistance value in the circuit. Okay, so we have in here the formula for parallel connection. To get the total resistance in parallel connection of a resistor, the formula is RT equals 1 all over, do not forget this is all over, 1 over R1 plus 1 over R2 plus 1 over R3. And if there are lots of resistors connected in parallel, all you need to do is plus here 1 over R4 and so on. Okay, so this is below, this is our example diagram, sample schematic diagram for a resistor, 3 resistors connected in parallel. Okay, so we will have here, so let's try to solve for the total resistance. Now this time, bear in your mind that we are now working on the parallel circuit. So we get here the given, these are the given values, the same value as what we have a while ago, but the connection of the resistors now based on this given diagram is different. They're already on parallel, but the value are the same. So R1 for 2 ohms, R2 for 4 ohms, and R3 for 6 ohms. Okay, so I hope that is clear. So we have here the solution. RT equals 1 all over 1 over R1 plus 1 over R2 plus 1 over R3. So if we are going to substitute this value in here in this formula, then we can have here below 1 RT equals 1 all over 1 over 2. This is 2 is the value of R1. That's why we replace R1 here with 2. Then plus 1 over R2, that is 4 ohms. So we got in here 4. So this is R2, this is coming from here from the given. So again, 4 ohms is coming from here, the given, and this is for R2. Then we replace R3 in here with 6, because R3, based on this given here, is equals to 6 ohms. So we got this number now. We have 1 all over 1 over 2 plus 1 over 4 plus 116 or 1 over 6. So from here, we can come up with this. So we have to find the LCD of these 3 denominators in here. So that is 2, 4, and 6. We could not have 6 because 6 is not visible by 4. So we have here 12 as our LCD. Now, 12 divided by 2 equals 6 times 1. So we got in here 6 over 12 plus 12 divided by 4. It's 3 times 1. It becomes here 3 plus 12 divided by 6. It will become 2. And times 1, it will become 2. Because we could not add fractions unless their denominator is the same. So that's why we have to rewrite this way. We have to simplify. So our new value now will become 1 all over 2 over 12, 6 over 12 plus 3 over 12 plus 2 over 12. And to simplify this, we have here 1 over 11 over 12. So this is a complex fraction. We can rewrite also this one. I'm sorry, I got mistake here. It should be rewrite as 1 over 1, so we can get the reciprocal. If you are to get the reciprocal, what will happen? It will become RT equals 12 over 11. So all you need to do is to get the reciprocal of the denominator fraction, proceed to multiplication. So that is 1 over 1 times, supposed to be that it becomes 1 over 1 times 12 over 11. So that's why we have here a 12 divided by 11. That would be equal to 1.09. As we rounded off this answer into two decimal places to have, for us to have to, I mean uniform answer, you need to round off our answer into two decimal places. So we got in here. For this example, our total resistance value is 1.0 ohms. Okay, 1.0, I mean 1.09 ohm is our total resistance. Now, based on our previous description on what is the answer on the parallel connection, what's the total resistance on the parallel connection, it says that the total resistance in parallel connection is lesser than the smallest value in the circuit. Now, you look at here, this is our circuit. The smallest value in here is the R1, which is 2 ohms, and our total resistance in here is equal to 1.09. So this verify that the total resistance of parallel connection is lesser than the smallest value, because the smallest value here is 2 and this is lesser than, and that is correct. So the description itself there is correct. Okay? Okay, next. We have here, so this time that is actually the, what we have a while ago is the calculation on how to compute for the total resistance if the resistors are connected in series or the resistors are connected in parallel. Now, this time is we will discuss on how to identify the resistors conditions. So these are the process. So we have in here, it could be the settings of your multitester before measuring any resistance. This is the reminder. You have to bear this one in your mind, that before measuring any resistance, you need to set your multitester into accurate or appropriate settings in here as its multiplier. Of course, depending on the voltage, I mean the resistance value that you have in your resistor. As you have a higher resistance value, you need also to make sure that you use also higher settings. And then, before measuring any resistance, after selecting the range that you have in your multimeter, is you need to make sure that the needle pointer is resting exactly on 0 ohm. So again, you have to set your needle pointer exactly on 0 ohm every time that you are about to measure resistance on your resistor. So it should start from 0 ohm for you to get the accurate resistance reading on this meter scale in here inside of this multimeter or analog multimeter. Now in here also, for example, these are the meter and this is the position of the needle pointer. Then all you need to do is to calculate the reading based on these lines in here. You have to calibrate what is the equivalent reading. Of course, you have to consider also the multiplier that you use in your range selector. And then, how will you connect the task proofs towards your multitester? It should be this way. One task proof should go on the other leg, and the other task proof should go on the opposite leg of your resistor. That's how are you going to position your multimeter towards your resistor. Okay, I hope that is clear. And the next one, testing of resistors. Now, there are steps or there are things that you need to do in order for you to know the condition of the resistor. So, the first one we have here, identify colors printed on the resistor's body. So, in a resistor, you need to find out what are those colors printed in its body, because those colors will give you a specific value. Okay, so for example, there is a green, red, brown, and so on. So you have to list it down or try to identify the color. That's the first thing that you need to do. Identify the color. So it's either it is blue, it is a red. So you need to identify. So again, the first task is just to identify the color. Very simple. Next one is get the color code value. So after getting the color, you need to know how to compute the value, resistance value of this resistor using the color code. So that is color coding system. So you must be able to identify what is the value based on those colors printed on its body. So the first is to identify the color. The second is to identify the resistance value using the color. That's why you need to identify the color clearly, correctly. for you to get also the exact or accurate value, resistance value based on the color code. Okay? The next one, if after getting the color code value is you are to compute for the minimum and maximum. Okay? The minimum and maximum is you will be your basis to identify the condition of your resistor. So that's why you need to be very careful in computing for the minimum and maximum. Okay? So next, for number 4, get the measured value. So talk about getting the measured value. This is referring to the actual measurement of a resistance using an instrument. So, for example, using multimeter. So, as what I've shown a while ago, you set your range selector into appropriate multiplier. Set your needle pointer exactly on 0 ohm by connecting the two test proofs. Yes, it should be staying exactly on 0 for you to have the accurate reading on the meter scale. Okay, that's it. So, that is how will you get the measured value. The actual resistance measurement using an instrument. So I hope that is clear. So number 5 is compare. So you are now to compare the minimum and maximum value towards the measured value. So you need, that's why you need to calculate or compute for the minimum and maximum value, because you will be needing it to identify the condition of your resistor, because you are going to compare the measured value. So from number 3, you are to compute minimum and maximum value. Then once you get already the measured value, then you are going to compare, because these are the two datas that you need to have for you to identify the condition of the resistor. Okay, so number 6 is upon comparison, so you can have now the comparison result. Now, this result will lead you to identify the condition of the resistor. So once you already have the minimum and maximum and the measured value, you are going to compare it for you to decide, for you to know what is the condition of the resistors. Now next, these are examples. So we have, for example, if you are given a resistor, so you are going to identify the color. So I guess we have here green, blue, and brown. Then we have here the gold as our multiplier. So these are the present color that we have in the resistor. So again, identify the color printed on resistor's body. So we have here again green. This is green. This is blue, and this is brown and gold. Okay. So this is a 4-band resistor. I hope that is clear. Next, after identifying the color, is you are to get the color code value. So color code value is based on the color coding system. Based on these colors, the color code value should be 560 ohms plus minus 5%. Because the tolerance here is gold is plus minus 5%. And this is green, this is blue, you have to write it, and brown is our multiplier, that's times 10. 56 times 10, it will become 560 ohms plus minus 5%. Okay, next. Have here, after getting the color code value, is you are now to measure, you are now to compute for minimum maximum. So how to do it? First thing is this value 560, you are going to get 5% of this. So 5% of this, how to, or what would be the equation? So that's 560 times 0.05, because you have to make percentage or change percentage form into decimal form. To make it, you have to move to decimal place. Of course, obviously, the decimal place is after the number 5, so move it to decimal place to your left, so it will become 0.05. And if you're going to calculate this, you can have 5% of 560 is 28. So we get here again, the 28 is the 5% of 560. And then after which is for the minimum, after getting the percentage value of the amount in here, for the minimum, you are going to minus, that is why we have here plus and minus. You are going to minus this percentage from the value itself. So this 560 minus 28, it will give us 532. Okay? And for the maximum, you are going to add. That's why we have here plus and minus. So for the maximum, that is this value here plus the percentage value, that is plus 28, and it will become 588. So now our minimum and maximum value should be written this way, so for us to have uniform answer. So we have here 532 up to 588 ohms. So this is our minimum and maximum value. Okay, so that is how you are going to compute for the minimum and maximum value of your resistor. Color code value. From color code value, get the percentage of this value in here. Okay, as I repeat, get the percentage value in here, this equal to 28, then you are going to subtract from this value and add this value. So to subtract, that is to get the minimum. To add is to get the maximum. So again, you have to write the minimum maximum this way for us to have the same answer. Okay, I hope that is clear. Next here is get the measured value. So again, to get measured value, you need to set your range selector into appropriate thing, then connect your test probe this way. Of course, do not forget to set your needle pointer exactly on 0 ohm before measuring any resistance. Then for example, if these are the reading, we will just assume that this is our measured value, 550 ohms. That's based on the, we will base that from this resistor in here. So this is our minimum maximum. Then we got in here the sample, for example, is what I get when I do the actual measure the actual value. Then we have here 550. Then next is we are to compare. So compare the measured value towards the minimum and maximum. This is our minimum and maximum. Okay, based on our previous example, is the minimum is 532 and our maximum is 588 ohms. And then we get here the measured value as 550. Okay, we get 550 ohms. So it means you are to compare, and based on this data, the comparison result will say that the measured value is within the minimum maximum. So this 550 is within the range of this minimum maximum. Okay, this is our comparison result. Now, this comparison result will lead us into a condition of a resistor. So let's say, for example, these are the possible resistors condition. So measured value is within the minimum and maximum. So the condition is good. Okay? So again, if the measured value is within the minimum and maximum, then the condition of your resistor is good. Next is when the measured value is below minimum but not 0, because 0 is below minimum. Or above the maximum but not infinite, because if the resistance is very high, that's infinite. So it should be above the maximum but not infinite. So the condition is defective and under out of tolerance, because a defective has different category. Then we get in here, measured value is equal to 0 ohm. Once the measured value is equal to 0 ohm, your resistor is really defective, and that is under shorted. Shorted na. It means the one leg to the other leg are already connected to one another directly. So that is why it becomes a very low in resistance, and that is referring to a shorted. When we talk about defective open, it is when your measured value is infinite. So infinite is referring to a very high resistance. It's referring to a defective and open. It means we can no longer calculate. We can no longer measure the resistance value because it is too big. That's why there is no more connection. The resistance is too high. So that's referring to a defective and open condition. Okay, so that would be all. So the first thing, again, just a little recall. The first thing that we discussed here is about the calculation of the total resistance of a resistor, either it is connected in series or parallel. Then the next topic that we have here is identifying the condition of the resistor, that is the testing of resistors. So how to identify if your resistor is still functional, can still be used in the circuit, or needs to be replaced for your device to be fixed, something like that. It could be because there are times that could be that the reason of the trouble of your device is the defective resistor. So that's why you must be able to know to identify the different or the condition of a specific resistor once you are given with the different value, okay, or once you are given with a specific resistor. Okay, so we have in here as our example. You have to try this. You try to solve. So give the condition of the resistor. So what I need in here is the condition of a resistor. But of course, before you doing it, is you need to compute first. So we have here that this given here is already the coded value. Okay, this is already the coded value. This 8 ohms plus minus 5%. Then number 2, 15 ohms plus minus 10%, and so on until number 5. And below are the given measured value. These are tentative. So this is just example. We need to do. So this is our resistor 1. These are the measured value that, assuming that these are the measured value that you were able to get along the testing, the the actual resistor using multimeter. So these are the assuming measured value that you get. Then you are to identify what is the condition of these 5 resistors in here. So try to answer this, and we will find out if you really get the discussion that we have in a few minutes. Yes, last few minutes ago. So and then we have also here another one. So you have also to answer this in your notebook, or it could be in the paper. So we have in here the given are the colors, no longer the color code value. So the first thing is you need to get the color code value in here, this 1 to 5. Then calculate for the minimum and maximum, after which is you compare it to the given measured value here below. For number 1, of course, you consider this measured value, and so on until number 5. Okay? And then we will find out if you get the correct answer. So that would be all for today. Thank you for watching this video, and I hope you learned something out of this tutorial video. Do not forget to subscribe and hit ring button, the ring button for you to be notified for the next video that we have.